just for people to understand the application of data, I want to push you a little bit on the use cases of data that are in industries that you otherwise wouldn't think that data is important. Where do you think data can be useful when it comes to parenting?
There have been a lot of data-based research on working mothers versus non-working mothers. Where should you send your kid to school? Whether you should make your kid learn an instrument early on versus what age is the most appropriate age. So many. I mean, modern day dating, which is the left and right swipe, is all about data, nothing else. It's almost, these are almost products that are completely data dependent because they just collect agent data and on the basis of data do the matching with you. So from the old school Jeevan Sathi to the current Bumble, I think it's all data.
Starting his MBA or her MBA, if they are confused, right? So then they start their MBA, they don't know whether they want to get into finance or they want to get into consulting, they want to get into marketing. Generally, they're not very clear, right?
Right.
So how do they decide whether data science is right for them?
Data science is required for everyone. It is not about a right or a wrong.
It's just not an option.
I don't think it is. It might be for like the next couple of years, but you know, your careers are going to be marathons that you run for a really long time, and it's one of those toolkits that is great to have. Who is stopping somebody who wants to go into finance from going into financial engineering, or who is stopping somebody?
So even if I want to get into marketing, this data science will help me. Even if I'm going into finance, this data science will help me. Even if I want to get into sales, for that matter, this data science can still help me.
I'm convinced, for example, in finance and marketing, it might help you get a better job for sure, right? Sales has a lot of interpersonal skills, and it's still personal selling. By the way, one of my thesis research was on how data science or machine learning models can be leveraged to, you know, do better personal sales. So we're just that's still a domain that we are going towards. But yes, absolutely. I think everybody should learn at least fundamentals of machine learning. Yeah.
Got it. Understood. So let's talk about that, fundamentals, right? So what is the first class I should take? What is the second class I should take? Where should I start? Where should I finish? And when do I know I'm good enough?
Right. So fundamentally, the first class starts in your first term, which is your statistics. That is an absolute must-have. You can't do. You simply cannot do data without understanding statistics. The second one is optimization theory, or OR, operations research, which is a collection of, so once you have data, you've been able to make some sense out of the data. Now you may want to optimize or ask questions around a loss function, a reward function, and things like that. So that's also, these two are very fundamental when it comes to the theory. Then comes the engineering side of it, which is you need to have at least one coding language that you understand, which also is a term 2, term 3 period where you can pick up Python, you can pick up R, whichever one you like to pick up. We give an option of both. And then from there onwards, two of the most fundamental courses around the machine learning aspect are supervised learning and unsupervised learning courses. Too much jargon, but I think those four courses...
Where did machine learning come in? I thought you were talking about data science.
Interesting. We are talking about data science. We're talking about data science. Since we're talking about data science, you know, in a business sphere, so when I say data science, as I was explaining, it is a combination of these algorithms. You can call it machine learning algorithms, or you can call it systems that can pick patterns. They're basically systems that can make some prediction or pick up some patterns on the basis of data, and that got coined as something called machine learning per se. Nothing but systems.
You have to explain again, sorry.
These are...
As you can see, I'm quite stupid, so you'll have to...
No, that's not... it's a buzzword. Machine learning per se or data science, these are buzzwords. So I'm trying to break it down for you and for people who are listening to us, and saying that, you know, keep the glamour aside. What is it really? It is computational statistics.
But that's also another buzzword. That's a jargon. It's a jargon.
It's actually not.
It's a jargon though.
So, okay, you understand the word computational. You need computers to do this now.
Okay,
You will
okay.
not be able to do it by hand or manually because of the large amounts of data that you have or the kind of patterns
correct.
you're trying to recognize. And it is statistics.
Okay.
It is fundamentally statistics. There is nothing, the more...
No, again, I'm going to ask my question again because I feel I have to make it more simple for myself. What is machine learning? And how is it different from data science? Or is it part of data science? Or is it in the same Venn diagram? I mean, how does it work?
I explain this as a Venn diagram in class a lot of times, right? So I say that cybernetics was the bigger question and like the bigger thing that came.
No, I don't want jargons.
Again, let's not go into jargons. Okay, fine. So anything that a computer can do for you or anything a machine can do for you that makes your life simpler, that's the broad, biggest
Correct.
circle in your Venn diagram.
Yeah.
Within that circle, you place a smaller circle, which is the machine learning one, which is completely inside your bigger circle. And machine learning is where pattern recognition happens. So you have a lot of data and you're trying to figure out some patterns out of that data. That pattern could give you some predictive power when you position it.
Example.
So, for example, just the way we were discussing, right? If I were to look at your market basket data and figure out if you're a price-sensitive customer or not, right? I'm trying to figure out patterns. I'm trying to figure out that, oh, Pratham buys this product a lot more when it is priced less, but not that frequently when it is full price. It's a pattern that I picked up in your data. When you were watching Netflix...
So to be able to do that, that algorithm or that code is machine learning.
Yes, that algorithm or that system is machine learning. How now? Okay, that is a logic, right? That's a logic.
So machine learning is the tool.
Yes.
Data science is the application.
Yes. Data science depends on machine learning. So data science is a combination of machine learning and business.
Got it. So the coding part of data science is machine learning.
Per se, yes. The data cleaning, data processing, yes,
the algorithm writing, all of that. That's machine
logic
learning.
Building, all of that is
so you start with statistics, then you do optimization.
You do the language.
And with which you will build ML models.
Yes, and then you do 2 courses, which are the fundamental courses on ML, the simplest of the ML models.
Where you're helping students understand how to actually write that algorithm
how to write the algorithm
using either R or Python.
Right.
And then what are the next courses?
So now at this stage, somebody could, and by the way, at this stage, you've done a lot more than, let's say, a typical B school grad would have done with your understanding of business. And at this stage, somebody can now say that, okay, fine, I know enough. I want to enter marketing. This is enough for me to, if in case I have a project where I need to work with a data analyst or a data scientist, I'll be able to understand this. After this, I want to do management consulting. Fine for me, right? After that, the courses go into much more kind of nuanced things. So there could be courses. So then we go into courses which are around applications. So financial analytics, retail and marketing analytics.
So how data science is applied to these domains.
So
and there are separate classes
so
for
there
that.
are domain specific classes. Or then you can kind of go much deeper theoretically also.
And in those classes, you basically do case studies, right? Essentially.
Absolutely. It's real data or like...
real clients?
Sometimes, yes. Real clients also. It's a little muddy, right? Datas are really muddy when it comes to real clients, and sometimes for the class environment we might clean data beforehand. So like for example in the agri-tech thing, I cleaned the data much before giving it to the students, but yes.
So is data cleaning also its own class?
It could be. Most times on undergraduate levels it is actually, but for MBAs I think they usually have team members who would do it for them.
Got it. So one way is the application classes. The other way you said?
The other way is to go deeper then
into the tech.
Into the tech. So like from machine learning, a very small component of machine learning is deep learning, right? Which is us trying to figure out how brain works and how brains decide, the neural network component of,
Okay, what is the application of that? Why do we go into so much depth?
Why do we go into so much depth? Because that is also heavily being utilized right now. For example, you will need to have a fair understanding of these deep learning algorithms to be able to actually build a recommender system because,
Okay, so machine learning itself is not enough. You have to know deep learning as well.
If you want to get into that specific
or
domain.
that sophisticated.
Yes, natural language processing, the way we are talking. If a machine wants to understand what we are saying and what that really means, that is a component of sort of deep learning called natural language processing. And then for that also, you again need to go deeper. Computer vision is something else. How does a Facebook says that this is your face, this is Pratham? How do you tag it?
So as an MBA student, do I need to know deep learning?
It is purely, I think that it is dependent on if you're really interested in going tech. I believe that there is a lot of scope for all of these things, especially in businesses like Netflix, Amazon.
But Netflix, how many data scientists it would have? Maybe 10, 20, 50? I mean, if I'm graduating B school, do you think I'd get a deep learning role or a deep learning?
I mean, a Netflix might not have let's say a very large pool of data scientists. Do you believe that an Accenture would have a lot of MBA
absolutely.
hires?
Yeah.
So they work on NLP projects, they work on computer vision projects, they work on that. So Accenture, Deloitte, the big fours, everybody is working on
as an MBA
projects.
student, if I have that deep learning background, I would be able to apply deep learning better to solve business problems.
Absolutely. You'll always be solving. There are no problems if not business problems.
Correct.
Everything is about economics.
So the MBA aspect of it, would help me figure out what the problem is. What are the problems that are worth solving?
And that is a very important thing. I'm so glad that you brought that up, right? Because a lot of times now that we have the toolkit to solve so many things, we often fail to recognize if a problem is actually an important enough problem to solve or not. And that's where that's also a difference between like a manager and a good manager and a great manager, right? To figure out if this problem is actually worth the time and effort of the team.
Got it. So let's go a little bit off-road now, okay? So, just for people to understand the application of data, I want to push you a little bit on the use cases of data that are in industries that you otherwise wouldn't think that data is important. Okay, let me give you an example. Where do you think data can be useful when it comes to parenting?
Wow. Parenting. I think there could be a lot of data points where, I mean, it's not new, but there have been a lot of data-based research on working mothers versus non-working mothers, mothers who spend time at home, different types of early stage educations and which education is doing better, where should you send your kid to school, whether you should make your kid learn an instrument early on versus what age is the most appropriate age. So, so many. Dating, oh wow, it's a fundamental matching problem. It is something that has been on and on for a lot of time. I mean, modern day dating, which is the left and right swipe, is all about data, nothing else. It's almost these are almost products that are completely data dependent because they just collect agent data and on the basis of data do the matching with you. So from the old school Jeevan Sathi to the current Bumble, I think it's all data. Construction, it could be about material, tensile strengths of material, placement of how you should do it, how many floors would be relevant, what kind of architectural elements you can bring around. Again, something that can be
As a business school, what can we do with data?
As a business school, what can Masters Union do? So much. We can actually leverage data in order to figure out who could be the right candidates. We can simplify our admissions process using that. We can also simplify our placement shortlisting on the basis of that. As is, we are using a lot of data which we generate on feedbacks in order for us to enable, faster resolution to things, and in order to improve our course content. We could also do some sort of analysis to figure out which courses are doing better than others. And
so can we also, like, for example, we have a classroom camera, right? So can we record the entire class and use a computer vision ML algorithm to identify in which teacher's class most number of students are sleeping? Is that technically feasible?
It is feasible. Is it a problem worth solving?
Yes, of course it is.
But it is very much feasible because, see, I would say it's actually almost easy because all you need to do is identify those data points which are indicative of somebody sleeping, and I mean,
just run the process.
Yeah, it's not going to be that hard.
Got it.
Only that our camera quality would have to be really good. But other than that, yeah. If we have good pixels, then that's not a problem at all.
Okay. What about like pets?
Pets?
Yeah, or pet care in general.
Interesting. You may be able to like I know for a fact that somebody was trying to build this solution where on the basis of like the skin of your pet, they would just scan the photograph and be able to figure out if what is the problem, what kind of allergy and what kind of solution there should be there. I don't think they were able to be very like they're still working on the prototype for it, but that is something that that can be used. You could check data in order to understand which kind of food compositions are doing better for a particular pet. They actually did that for making these dog food and everything. They actually check what composition does better for the dog's health and things like that. So much, right? Our in-house people are trying to make a build. There is a student group that is trying to build an app which could make recommendations on the kind of recipes that you would like. Okay,
so let's talk about that. That's actually interesting. So, so we have a team which is part of our venturization program, and they are trying to solve this problem where. Essentially on Zomato, you spend a lot of time just figuring out what to order, right? And they're going to solve that problem by helping you recommend foods.
Right.
So 2 questions. One is, why doesn't Zomato solve this problem by themselves? Right? They should have by now. If Netflix has, why haven't they? Number 1. And number 2, how are they solving this problem? Without revealing any trade secrets, because it is a data science problem, right?
Right. It is very much a data science problem. It's actually very much a recommender system problem, and something that's very interesting to me. Why is Zomato not able to do it? It's not that they did not try. It's a very hard problem to solve because unlike a yes and no, whether you would like this movie or not, taste preferences are very dependent on your where you come from, what you grew up with, who are the people around you.
But that's similar for movies. I mean, I like the kind of movies it depends on how I've grown up, right?
Right. I mean, a lot of times, yes. But see, here's my thing. When you watch a movie, the number of hours that you're watching a movie, first things first, you might actually rate your movie. Right? Second thing, even if you don't rate your movie, the amount of time you're watching,
so they get the feedback.
You get some form of proxy for
correct. So Netflix gets the feedback.
Yes. So I may know that Pratham likes this movie little bit, right? Because Pratham watched it for half an hour, but then kind of did not like.
But Zomato would know if I ordered thrice from the same restaurant.
Yes, but would it know if you ordered it from once and then you just left it midway? It doesn't. Yes, it might know. So if you ordered thrice from the restaurant, that's very simple. That's heuristic. That doesn't need a data science. That's just number, frequency, and recency, right? That is nothing.
And they do that. If you already
they already do that, right? But when it comes to food preferences, that is a very big challenge. Even academically, that is considered to be a really big challenge. To predict things like what would you like to eat is something that if these guys are able to solve it, it'll be groundbreaking. They are making some headway there.
That's amazing.
Yeah. So it'll be.
So if there are any VCs looking, watching this,
it's a very interesting problem.
This is very cool.
Yeah.
This is very cool. Okay. So we have these students who are working on this food project, right? Which is called Zood. And that what they're trying to do is essentially help people order quicker, because there's a lot of time spent on just figuring out where to order from and then what to order.
Right.
So the paradox of choice, they're essentially trying to solve that.
Yes.
So how are they solving it?
They're trying to solve it by they're trying to solve it by understanding the food preferences that people have, right? So in a way, think of it as more a probability kind of a setup where you're trying to figure out if I was to offer a pizza to Pratham, what is the probability that he will eat it right now? And they're kind of trying to figure this out in such a way that if you get a high enough probability for a particular type of food, then hey, let me recommend this food, or let me recommend these 3 different dishes to this person. And then, I know with high probability or high chance this person is going to eat it.
So then that would depend on where I come from, what are my previous orders,
Absolutely.
Where do I live,
Absolutely.
Am I North Indian, South Indian, West Indian, East Indian, which state I'm from, all of those things will impact, right?
Yes, very much. And also the time of the day, there are a lot of aspects to this, right? If you go into the depths of this, it'll almost be like if it's raining outside, you may want to eat something different than if it is sunny outside. If it is a meal time versus a mid-meal time, what would you like to have? If you're ordering alone, or are you with people whose preferences then also come and play a part in this picture? So that's why it's a very, very complex problem. And one of these bits
so if they're able to solve it, that's a billion-dollar company right there.
Oh yes, absolutely. It's going to be massive because I think this is a problem that academically also people have been trying to solve. I for once tried to solve a little bit of a piece of this problem in my PhD thesis, and it's largely a question that people want answers to. But again, the way brains function, the way our taste preferences are, is something very, very complex. It's right now very aspirational to think that a machine will be able to figure this out.
Yeah, a machine cannot be your mom at the end of the day.
Yes.
So it's interesting, right? So these were business school students. And because they study data science in all of your classes and everything, they probably understood that, hey, there is a problem that can be solved. And it's a business problem.
Yes.
It's very much a business problem. If Zomato can solve this problem,
right,
I mean, it would help them, get that many more orders.
Yeah,
so it's a business problem.
And it's very funny, this problem, kind of this discussion with the Zood team started happening in term 1.
So Z-O-O-D.
Z-O-O-D,
Okay.
yes, Zood. So it started happening in term 1, and the problem was completely different. They were they kind of wanted to do something around recipes and regional recipes and how you can cook regional food very authentically. And that kind of transformed into what we see as a problem right now, all thanks to the business courses and the tech courses that they have been doing. It was initially not even a platform that they were trying to build. It was a completely different problem that kept getting reformed every single course that they did, every single term that they went through.
You should host a podcast with the Zood team.
I should, absolutely.
I think that would make for a very interesting, what do you guys think? We should totally do this.
That'll be nice. Actually, not just the Zood team, even the other teams, the Fantouche team, which was earlier called the Movie Meta team, are trying to build, really good platform for quizzing and, especially Bollywood type of quizzing. And again, there's a lot of data there and work that can be done on the basis of data, recommendations that can be created, ratings that can be formed, and things like that.
And here, let me just share one of my experiences. So when I was in college, I started a company called Outgrow. And we are a platform where companies can build quizzes, right? So for example, we have a quiz which was created by New York Yankees, which is one of our clients. Yes. And it's a baseball team in the US, in New York. And so they have a quiz called, which New York Yankees player are you?
Right.
Okay. So they try to match your personality with one of their players' personality and try to just sort of build that loyalty with their brand, right?
Right.
So they have maybe 25 players, and you take this quiz. It asks you, what kind of beer you like, what kind of shoes you wear, if you had free time, what would you do, right?
Right.
And for people who are Yankees fans, for them to understand which Yankee player they're most like, that's a very important question in their life.
Absolutely.
Right. Now, I saw this quiz, right? And one of the questions was, as I mentioned, which beer do you like, right? What I realized later on what they were doing was that they were taking the results of that quiz. The result was, a list of people and what beer they like. And they sold that data set to Budweiser.
Right.
So now Budweiser knows that these million people who have taken this quiz, how many of them like Budweiser?
Right.
How many of them like their competitors?
Exactly.
And that is amazing data for Budweiser.
And this is, by the way, TG that watches
exactly.
this, right?
The baseball people love drinking beer.
So then Budweiser also decides on the basis of that if they should be advertising during a Yankees game or not.
Sure.
Right?
Yeah, of course.
And then on the basis of that, they realize whether they want to sponsor a team or not. They want to have hoardings there or not. So these kinds of context-dependent
I'll tell you one more thing that they do, right? Which is the most interesting. So when Budweiser then retargets you with an ad on Instagram, you know who's holding the Budweiser beer in your ad?
I'm sure the person who came out to be
most like you, right? And so what they told us was that when the person who you most relate with in the team is holding the beer can, the conversion rate or the click-through rate on that ad is like 6-7 times more than somebody else is holding that beer can, right? And that is how, data is being used in marketing as well.
Right. Advertising is something where most companies and most, the Facebooks and Google kind of, and by the way, like, don't take me wrong, this is my point of contention with these firms. Actually, they could have done so much more than just advertising, but they kind of are using their data to the most potential for better targeting, for more advertising, whereas they could have built much better products. And this is a different conversation altogether around ethical use of data and so on and so forth.
That's for a separate podcast.
That's for a separate podcast altogether. But yes, advertising and targeting is something, and personalization and things like that has been one of those things that, data science kind of thrived upon. So the Clive Humby I mentioned in the beginning, who gave this statement, data is the new oil, was actually doing the same thing. His company called Dunhumby, which was also my first employer, were actually creating a lot of these advertisements and a lot of these marketing targeting. Yeah, they used to have a running joke where there was this we had this fictional character called Katie, and we wanted to give Katie soup when it rained, and that's how our models were built. Will it be able to give Katie soup where she is on the day that it is raining?
Wait, I didn't get it.
So so we kind of wanted our model to be so good at targeting that when it is raining and Pratham is in DLF Cyber Park, I send Pratham a coupon for Starbucks in DLF Cyber Park and tell him, hey, if you get a cappuccino because it's raining outside, might as well come in and, take this discount from us. And that's how good we've gotten at targeting.
So what I'm realizing is data is actually a lot more sexier than what people expect it to be.
Yes, it's I say both, right? It's a lot more sexier than people assume it to be. It's also a lot more harder than people assume it to be.
No, we'll not talk about that. We want people to do it.
People will be able to do it. I think the problem, or a lot of times, there is a lack of understanding on the fundamentals. And I will just say this, that actually being in a school that focuses both on the fundamentals and the applications is the right way. Not learning just one will not do it for you. Yeah.
Got it. I mean, I think if you're looking for a job, right? And I think we've spoken about this before, but let me just reiterate. If you're looking for a job in marketing, I think you'll be much better off in the marketing analytics part of marketing than just simple marketing. If you're in simple marketing, you're very dispensable, right?
Yeah.
But if you get the analytics aspect of it right as well, then you are sort of sone pe suhaga.
Right. But it's there is merit in answering the question, who is actually doing traditional marketing anymore? Are you run companies? Are you doing any form of traditional marketing that is not data dependent?
I mean, even if I am, it's maybe 5% of the time.
Correct, right? Yeah. So that's not a majority of your chunk. Sales, yes, people still do very traditional methods of sales because, again, as I've mentioned, there's a lot of interpersonal skills and building of relationship that is required. But in marketing, pure and pure, you want to understand if my target audience is perceiving my product or my service in a good way, and how can I make that better? How can I identify my target audience better? How can I make my product better? How can I sell more of it? Those questions require, when you have the data, why would you go another route?
Yeah, got it. So Nandini, let's switch gears and talk about you, right? Could you take us through your journey, right? In the introduction, we covered, that you did your undergrad in math.
Yes.
And thereafter you did your PhD in data.
Right.
But could you tell us your decision making? Did you use some data to figure out that you want to do this? What was your journey with data like?
Right. So essentially, I kind of started off with my undergraduate degree in pure mathematics and realized very early on that pure mathematics is something that I see very little use of when it comes to getting a job and, things like that. So towards the end of my data journey, I got my first job, which was essentially in risk analytics. So this
is after your PhD?
After my undergrad.
After your undergrad.
So after my undergrad, I did a job for a year, which was a risk consulting job. And that was my first exposure to building probabilistic models and understanding better. So there used to be this team, which was considered to be the sexy team there, which were the ones who were building the models. And when I went and asked if I could be switched to that team, they said, no, the original, I was just doing, I was an undergrad, so I was doing QCs and I was doing very basic work, right? So
QCs?
I said, quality checks and just checking if the model is right or doing scenario testing and things like that, not really building the model from scratch. And I said, what do I have to do to get into that team? And they said, you have to study further, get a master's degree, and then you will be able to do it. So then I went into a master's degree, which was more applied mathematics, and I did operations there, and optimization were my primary subjects, and I studied that. And while I was doing that, I interned for a longish period of time with Dunhumby. So I learned the facets of retail and marketing analytics there, and got introduced to this, merger of business with analytics. Earlier, I was just working on statistical models. Now, this was the first time when I was saying, okay, fine, how do I apply this to the business and what does that do?
So how did you apply it at Dunhumby?
So, for example, in Dunhumby, I was working with Kroger, like the team that I worked with Kroger, which is a retailer in the US, and trying to understand if, so I was basically trying to use data to understand their loyalty programs better. So, what kind of coupons or what kind of marketing should I do for my consumers to engage with them a lot more, and this was different for different target groups within the loyal customers of Kroger, and those were different models that I kind of built, and then Kroger used to apply those, and then we used to see if there has been a change in new card sign-ups or increase in sales because of that, and so on and so forth. And again, another team was working with Macy's. There were people who were working in Walmart.
So you did that for a year?
So I did that for almost that long, and then after that I had a job from Dunhumby, which this was still my internship, but I had a PPO.
During your master's?
Yes, I had a PPO from Dunhumby, which I did not take because I got through the PhD program at Indian Institute of Management, Bangalore, where I got into the quantitative methods area, which kind of combined, again, both. It was a marrying of all the quants that I have done in life so far and the business school setup. And therein, while I did a lot of projects here and there and a lot of consulting work, most of my PhD work or most of my research was around recommender systems, which is, I worked with a particular type of algorithms called the multi-arm bandit algorithms. And
so you have to speak slowly.
Yes. So
this is probably something you've spoken 100 times, 1,000 times, but slow.
So within the domain of machine learning, there is something called reinforcement learning. Recommender systems that we have spoken about so much are a part of reinforced learning, which is that every single time you interact with that setup or system, the whole thing will change, right? The moment you watch a movie, your recommendations automatically change. The moment you buy something, it's very dynamic. So it's like almost a loop that keeps on running. That is a reinforced algorithm. It gets reinforced over and over and over again.
It improves with time and data.
It improves with time. It is supposed to improve with time. There is, an associated reward that somebody is seeing when you watch more of it. And basis that reward, they are able to rework the whole thing. And within this sphere, I was trying to explore whether this theoretical work that has been done on multi-arm bandits, which I can explain, is actually, if there is merit in positioning that in reinforcement learning algorithm work and to make better digital marketing decisions.
Now let's talk about the
multi-armed bandits. Okay. And it is exactly what it sounds like. So it comes from the story of multi-armed bandits is very the name comes from casinos. So casinos have single-armed slot machine, right? So you pull the arm of the slot and you get some reward. Now I don't know if you're aware, but the background of that reward is actually a probability distribution.
Okay.
Right? So how you will get a reward in that slot machine is dependent on some underlying probability distribution. You as a player don't know that.
Normal distribution.
It's not normal,
it's
actually.
Not normal. Okay.
If it was normal, then anybody will be able to play it enough times and still win. It's not normal, actually. Quite the contrary. It's very skewed. And it is something that changes frequently also along with the plays. Now imagine instead of having one arm to pull, you have multiple arms to pull. It might be there might be merit for a player to see if, hey, when I pulled the second arm, I got a lot more reward than when I pulled the fourth arm. So should I keep playing the second arm or should I explore these other things? So it's almost a balance between, I know for certainty this thing is giving me reward. Should I continue to do this or explore more?
Okay.
And as we all know, the house always wins. That's where the bandit word comes from. There is no winning in this algorithm. You continue to keep learning more and more. You continue to keep exploring while also exploiting. So it's a balance between explore and exploit.
Okay. So you spent 5 years doing this?
Yes, about a little longer.
But why?
But why? Because...
what is the business use case? How can I use this in real life?
Have you heard of A/B testing? Have you used A/B testing in your work?
Yeah, of course. I mean, we have a website and it has 2 versions always running.
Correct.
And then whichever one has better conversion,
correct,
we use that.
Right. So now tell me one thing. You take a period of time and you run this both in parallel, giving it to, let's say, half of the people
Correct.
here and half of the people there, and you run it for some time, and then you see which one was doing better.
Correct.
And you pick that version, and then you show that version to everybody.
Correct.
That's a very static way of looking at things.
Okay.
Now, my suggestion to you is you continuously run both.
Okay.
And it might happen that on Mondays and Tuesdays and Wednesdays, your
One of them
first
works.
is working better. And in those days, you actually spend 70-80% of your traffic to that side. But keep exploring that other one, because, hey, might happen that on the weekends, people like that version
So you've
better.
added a variable, which is time.
Not just time, again.
Oh, you can do other things,
I
okay.
can do many, many more things to that
Got it.
variable. So now, and surprisingly...
So you say in the US, this one is working better and this one's working better in India.
Yeah.
So in India, you show that. And
Yeah.
the US, you show that instead of showing one to all.
I'm saying even in the same audience, you are separating the you're separating the population for me. I'm saying for the same set of people, it might happen that sometimes one ad is doing, like one version of your website is doing better. Sometimes the other version of doing it better. Again, it's the human brain that we don't know why.
So many variables.
There's so many variables. Why make it so static that you will run it for this? And luckily for me, Google has recently started exploring multi-arm bandits as a replacement for A/B testing. So who knows? My work might actually see. My work was very, very theoretical, but it might actually see some. Some applications happening in Google
I understand
too.
this because I understand A/B testing. But for someone who's listening to this for the first time, it might be a little bit complicated. So where do we get more information about this? How can we download your paper?
Google Scholar?
Okay.
Absolutely. Yeah.
So what do we search?
You can just search for my name, and there's only one Nandini Seth who actually is on Google Scholar,
awesome.
and you'll be able to find more of my work, not just in this domain, but other domains as well.
Essentially, your research is helping further optimization.
In a way, yes. It's actually a very... the problem with multi-arm bandits is, as I was explaining it to you, you'd be able to recognize it's very complex. There was a joke that multi-arm bandits came around World War II time, and there was a joke that you drop this on the enemy and the war would be over because of how complicated it is.
Got it.
So it is complex. It'll take some time for us to completely understand the grasp of it. I actually worked on I used multi-arm bandit for a bit on the VMware website to kind of see how things are working. We were able to get some success, but I'm so sure that with more people working on the problem now, I think we'll be able to see. I do see that A/B testing will get completely replaced.
So do you think the Zoot people can use your...
Yes. But I would first like them to build a basic model and then kind of complicate it a little more. I've asked them or suggested to them to build the model on very fundamental...
Do you think Netflix uses multi-arm bandits yet?
Netflix, they've been doing research on this. I am not quite sure if they've applied it or not. Google has been on the forefront of utilizing a lot of multi-arm bandit models. Yeah.
Awesome. This is very interesting. I didn't know this actually about your research. Awesome. Are there any questions I should have asked you that I haven't?
That you should have asked me. A lot of times people ask me a lot about, because I love to read history of things, so a lot of times people ask me the history of where statistics came from. That's usually how I start my first class also, giving them the whole...
So where did statistics come from?
So statistics kind of came from probability theory, essentially. And probability theory came by people wanting to understand gamblers and their behavior better.
Okay, so the beginning of statistics lies in gambling.
Oh yeah, the beginning of most things in world life.
The math world.
Yeah, in the math world. Not math world, the stat world. The stat world is slightly, it was much later than the math world actually. And interestingly, did you know that statistics was actually called inverse probability for the longest time?
Like the field of statistics?
The word was not coined. It was actually called inverse probability, because when people were studying probability, they used to say that, hey, here's this thing, I have been, I have a fair deck of cards, and 3 cards are dealt. What is the probability that I will get 3 aces? It's a very simple, fundamental thing to understand, as long as you know that...
1 by 52 times 1 by 52 times 1 by 52, right?
Yes.
It is? Okay, good.
Well, not 1 by 52. The moment you have 1 by 52,
1 by 51, 1 by 50, sorry. Yeah.
Right? So, ideally, that is simple. You are saying that there's a setup. What is the data that I'm likely to get out of it? Then people started wondering what will be the other way around, the inference, like the inverse of this. If I have data, can I say something about the phenomena that was occurring?
Okay.
So it was almost like saying, hey, I think 3 out of 10 times Pratham ends up getting like, this kinds of cards. What is the phenomena that is happening? Is that actually a fair deck of cards or not, right? And that became the inverse probability in a philosophical way. And
so to
that's
predict gambling results, that's why statistics.
You predict. So gambling result prediction was probability. Understanding what the gamblers are playing was kind of inverse probability, which was statistics. And then over years, I think this French gentleman, Duplass, was the one who kind of statistic, or the word kind of comes from state or stata, which in French means the study of state. And he kind of was using these very fundamentals of statistics or inverse probability at that time to understand. He worked with Napoleon, so he wanted to understand the French like distributions of how people are, what are they doing and what are they up to, what are the age distributions and things like that. And that's when he coined this term. And from 30s on about later is when it came to be known as statistics.
Awesome. Very interesting. This is so. I mean, I didn't think that a conversation on data would be as interesting, and that data would actually turn out to be this sexy. So I think thanks so much for touching on all of these aspects. I think we touched on how data is useful in pet care and how data is useful in Amul's marketing department
and in dating.
And in dating. Yeah. And it's all very convincing. Yeah. It's all very convincing. So, any last words for people who are watching this? And you want to sell your course?
In God we trust, all else must bring data. So the Deming principle kind of like holds. I think people should really kind of start to acknowledge and start to buy the narrative that data is crucial for any form of business decision making. It is not just data science as a domain will cease to exist because it will become such an essential part of every single domain that you do, that there will be no specific certain like different data science division. It will be like every team almost has a data science person, or almost everybody in the team will be a data science person. So like Andrew Ang, who's like the modern day kind of, a leader on data and thought leader on data, always says that, I'm waiting for the time that all the mom and pop shops will eventually start using data. And he says that time is not that far ahead. So I think that. So, I mean, like in our, we have a program called the Venture Initiation Program, right? Where students start their own companies and then, we help them through it. And there's always a CEO. Right, who's sort of the lead, brings everyone together, the moderator. You have the CMO, the marketing guy. You have, or the marketing girl, sorry. You have someone who takes care of sales, right? Someone who takes care of tech, right? Someone who takes care of finance. I think we need to add a sixth person who takes care of data. Yes, absolutely. Right, so I think the chief data officer, chief data scientist is something that I think, at least in the VIP program, we should incorporate. Absolutely. Right. So let's say I'm starting a company. How soon or how late should I hire my first data recruit? If you've thought about hiring a company, you should have a data recruit to tell you what your company should be making and which market to be targeting. And how much should you... So at the idea stage, essentially. Oh, yes, absolutely. Sometimes the idea in itself could be data-driven, right? Yeah. Like Zood. Like Zood, for example. And that is where you hire a data person. So absolutely at the beginning. At the beginning. Yeah. Awesome. Yeah. Thanks, Nandini. This was exciting. Thank you so much. Absolute pleasure.